And this is Honors Algebra 2 Pre-Calc, section 6.5 of Pre-Calculus, which is trigonometric form of complex numbers. We're going to talk about DeMoivre's theorem, which is on page 453. This is another use but don't memorize. It's great if you have this memorized, but you certainly don't have to. I can't picture a situation where you wouldn't be able to look this up if you really needed it, and I don't expect that it's going to be something that you're tested on. It's certainly not in my class, but in anybody else's class necessarily either. So, Z is that R times the quantity cosine theta plus I sine theta. That's my general form for a trigonometric form of a complex number. Then Z to the n is equal to R to the n times the quantity cosine of n theta plus I sine of n theta. So knowing that, we're going to do example 6, which is actually from the book, and it is actually example 6 in the book, which is shocking. So we're going to go ahead and walk through this example. So the trick is that it's not going to be fun to FOIL this all out. I mean, there's probably somebody thinking, I could write this out 12 times and FOIL a bunch, and I suppose you could, but you would hate your life. So the best thing I can do here before I apply DeMoivre's theorem is I need to write this Z in complex form, right? So I know that my Z is a -1 plus root 3i, right? So I can find R by doing the square root of -1 squared plus a root 3 quantity squared, right? Which is going to be a 1 plus a 3, so I get root 4 or 2. Great, so my R is 2. Nice. That's convenient only because 2 to the 12th, because we're going to have to do a 2 to the 12th, is not completely disgusting. It's not super fun, but it's not completely disgusting either, and presumably you would use a calculator, or you play a lot of that 2048 game or whatever it is, and you're just really, really used to how to find this. So anyway, I also need theta, right? So I know that the tangent of theta is b, which is that root 3 over a -1. Now, the thing to be cautious about is to think about what quadrants I'm in, right? So here, I know that my y is positive, because that's what b is, and my x is negative, right? So I'm looking essentially for where my y is a root 3 over 2, and my x is a -1/2, right? Well, in order for that to happen, I'm going to be right here at 2 pi over 3. So my theta is 2 pi over 3, right? And that really requires some unit circle knowledge. Cool. So now I have theta and I have r. So now all I need to do is plug into DeMoivre's theorem, right? So I now know that my Z is R, which is 2, cosine of my theta, 2 pi over 3, plus I sine of 2 pi over 3. So using that wonderful theorem that we didn't have to generate from ourselves because somebody else came up with it, which is very helpful, this Z to the n, Z to the 12th rather, it's not an n here, to the 12th, should be a 2 to the 12th, because that's R to the 12th, cosine of whatever 12 times 2 pi over 3 is, which we'll deal with in a sec, plus I sine of, again, whatever 12 times 2 pi over 3 is. So 12 times 2 pi over 3 is a 24 pi over 3, right? So that's an 8 pi. So I get that this is 2 to the 12th times a cosine of 8 pi plus an I sine of 8 pi. Now, you don't think about 8 pi all that often because it's not on the unit circle, but here's what we know about our unit circle, right? These are all the even pi's, 0, 2 pi, 4 pi, right? Because this is 0, this is pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. So this is going to be on this side. It's going to look like this. So the cosine of 8 pi is 1, and the sine of 8 pi is 0. So my answer is going to be a 2 to the 12th times 1 plus 0, essentially. So your answer is a 2 to the 12th. Now, if you really didn't have a calculator or your brain was totally broken or whatever, you could leave it as that, but it is a 4096. Again, doubling is something that some of us do for fun, but also something that a lot of us do in random stupid games on our phone. So that's it.